So, good day everyone. This is your recorded video or recorded discussion for your Module 7. So, the topic for Module 7 is about static friction, wedge, and belt friction. So, nasabi ko yun, no, sa ano nyo, sa Module 6 nyo about sa mga support no, or reaction na nangyayari sa mga supports natin. So, dito, no, tatalakayin natin or tatakan natin yung topic about friction, no, kasi sa hindi lang reaction, no, sa mga ano natin yun, sa mga structures or tools or mga beams no or trusses. So dito naman no ang at naman dito friction naman no pag-uusapan natin with external forces no na apply no sa isang body. Okay, so makita niyo dito we have frictional force, coefficient of friction, normal force, and angular friction. So, alam ko na nataka nyo din yan sa physics. So, ito siguro medyo ano na lang to, no, overview ng module 7 nyo. So, friction of force na that resist, okay? The movement of two contacting surfaces that slide relative to one another. So, ano lang yun, no? Dalawang body na nagko-contact. So, nagkikreate yan ng friction. So, we have dry friction, friction force that exists no, between two unlubricated solid surface. So, walang lubrication, no? And then, fluid friction acts between moving surfaces that are separated by layer of liquid. Okay? And then, no, characteristic of dry friction. So, friction, no, yung sabi ko kanina, two touching objects which move relative to each other. So, this force often acts tangent to the surface at the contact points and is directed against potential or actual movement between the surfaces. So, when there is no lubricating fluid, dry friction occurs between the contacting surface of bodies. Okay. So, laws of dry friction. So, dry friction laws are exemplified no, by the experiment below. So, nakita natin dito, we have force and we have normal reacting force doon sa crate natin or sa box natin. So, the force is acting on the block or its weight, no, weight and force reaction. So, since the weight has no horizontal component, no, the surface reaction also has no horizontal component, no. So, weight lang yun, no, weight lang na nag-a-apply dun sa surface natin kung saan siya nag-a-act. Okay? And then, yung ano natin dito, suppose now, no, kapag naglagay tayo ng force dito, which is P or potential force na nag-apply dun sa banks, no, meron tayo nag-react na counter dito, which is yung friction. So, there must be some other horizontal force which balances our P, okay? So, horizontal force yung P natin. This other force is the static friction force na nag-act dito sa point, no, kung saan na-apply yung force natin. So, which is the product of a large number of force acting over the entire contact surface between the block and the plane. So, sabi dito, no, sa graph natin, increasing the force, no, also raises the friction force na nangyayari. So, continuing to oppose P or yung horizontal force natin until its magnitude exceeds a certain limit value, no, sa FM natin, which is yung tawag natin, yung maximum force no, na apply. So, if our horizontal force or P is raised further, the friction force can no longer control it and the block begins to slide. So, nag-slip na siya or nag-slide na siya. So, if the block is shifted, the magnitude of F decrease from FM to a lower value of FK. So, itatakal natin yan kung ano yung FM na yung sinabi ko kanina na maximum limit force no and friction force natin or our kinetic no kasi meron na siyang movement or nag-slip na sa nagsaslide parang gano'n. So, experimental evidence shows that the static friction force maximum value of Fs, no? So, yan, no? Force maximum value, no? Is proportional to the normal variable na n natin of the surface. Yung nakita nyo na, merong n doon, nag-act doon yung normal force natin. Of the surface reaction, we have Fs where, no? Yung coefficient of static friction. So, para makuha natin yung Fs or the static friction, no? Dito, times mo lang yung normal force mo to your coefficient of friction. So, the magnitude Fa of the kinetic friction force can also be put no? In the form where our mu k, no? Yung mu yan, yung mu, is the coefficient of kinetic friction natin. So, times mo lang siya para makuha yung force natin na kinetic or may movement na. So, our coefficient of static friction and our coefficient of kinetic friction, no, do not depend, no, on the area of the contact surfaces. So, but both coefficients are highly dependent on the design of the contact surfaces. So, the related kinetic friction coefficient values will be around 25% lower. So, mas mababa lang siya ng 25%. Where, no, yung UK natin or yung coefficient of kinetic friction, no, times mo or equals sa 0.75, no, or 75% ng ating uh, coefficient of static friction. Okay? Okay. So, next is uh, approximate values of coefficient of static friction or dry surfaces. So, meron tayong metal on wood, no? So, makita mo yung mga value, no? Or approximate values ng coefficient of static friction natin sa isang dry surfaces. So, makita yun sa module nyo, check nyo na lang no, kung ano yung magagamitin nyo. Kunyari, sasabihin na yung gagamitin natin is yung lower limit ng isang metal on wood. So, it's 0.15 or gamitin natin is yung maximum, no? Metal on metal or metal on stone, no? So, yan yung lower limits. So, lower limits, yan. Ito yung upper limits natin, no? Or minimum maximum natin na friction. Okay? So, be aware na o kung ano yung mga gagamitin nun. Especially kapag lalabas siya sa long quiz or exam natin. So, from the above definition, it appears that when a rigid body is in contact with a horizontal surface, four differential situation will arise. So, apat na situation na meron tayo, no? Depende dun sa magiging mukha ng figure natin or kung ano yung mga forces na na-apply dun. So the force sa first condition natin or first equation is the forces applied to the body appear not to move it along the contact surface. So there is no frictional force. So taas lang no whole vertical lang yung friction mo where your horizontal force is equals to zero. So simply our normal force equals to our vertical forces plus your weight. So sa second condition naman or second situation, the forces applied tend to move the body along the contact surface but are not strong enough to set it in motion. So konting force lang yung na-apply mo doon, no? Sa ano natin. So hindi siya nagkakaroon ng movement, no? Doon sa surface natin. So where, no, our horizontal force, no, and our friction force, no, is just equal. So the friction force F that has evolved can be found by solving the body's equation of balance. So since there is no proof that F has reached its maximum value, no, the Fm natin is equals to your coefficient of static friction times your normal force, no. Equation cannot be used, no, to calculate the force of friction. So hindi mo ito magagamit since equal lang yung force mo na apply dun sa horizontal mo, no? So, sinasabi niya na our force is less than dun sa coefficient of static friction natin times our normal force. So, no, walang motion na nangyayari. And then, next situation natin is the forces applied are such the body is about to only slip. So, konting movement lang meron, no? So, we say there is an impending motion. So, the friction force F has reached its full value and balances the applied forces along with natural force. So, you can use both the equilibrium equations and the equations, no, ng uh, friction force natin, no? Times mo dun sa ating equation, no? Where yung sinabi nga natin kanina ulit is yung static friction times the normal force. So we also note that the force of friction has a sense of opposition to the imminent motion. So yung motion natin is impending where it is in equilibrium. Kumbaga, nagka-counteract sila sa isa't isa. Yung force natin and our friction dun sa surface. So the next situation, no, or condition is under the motion of the applied forces, the body slips and equilibrium equations no longer apply. So, hindi na siya equal since, no, nagkaroon na ng movement dun sa force mo. It's either nag-i-slip siya or mas malakas na yung applied force natin na ina-apply natin. So, however, our force is now equal to your kinetic force and the equation, no, where is magiging kinetic force natin is equals to your uh, kinetic coefficient of friction times your normal force, no, may be used. And then the sense of FA is opposite to the sense of motion. No? So, opposite na yung nangyayari. Kasi nga, meron ka ng movement. Okay? So, mamaya, no, meron tayong mga sample dyan, no, to further discuss, no, kung ano yung nangyayari, no. So, ma-visualize natin siya. So, angle of friction, so nagkakaroon din tayo ng angle dyan, no? Especially kapag, ano siya, kapag nasa incline siya or we're moving that object, no? Papuntang, sa either pababa or pataas, mga ganun, no? Ng mga situation. So, replacing the normal force and the friction force F, no, with the respective R or reaction, no, reaction force is sometimes convenient. So let us consider again a weight block, no, resting on a horizontal surface of the plane. So if there is no horizontal force applied to the block, resulting R will be reduced to normal force lang. Okay? And then, however, no, if the force applied, no, has a horizontal component, no, kung makita niyo sa figure natin, no, na tends to move the block, no, the force R will have a horizontal components din. So, yung resultant, no, kung saan na-apply yung force, doon mag-a-apply siya sa surface natin. So, magkakaroon tayo ng angle, no? And then, no, the angle between our R, no, yung resultant and the vertical increases and reaches a maximum value, no, kapag tinaasa natin yung horizontal force natin, no, until motion becomes impending. So this value is called the static friction angle. So nagkakaroon ko na ng angle dito and indicates, no, by the phi, no, na sign, no. So theta kung sa angle dito, phi dito sa static natin or sa friction. And then movements, no, actually occur. The magnitude of the friction force drops, no, to our kinetic force. So similarly, the angle F between R and N drops to a lower value, no, na kinetic friction angle. So makita natin yung formula used, no. So simpleng tangent lang yan, no, where your Fn is your uh, yung pinanggalingan yan. So, kinetic and our static lang, friction. Where sa motion lang siya, I mean, wala siyang motion. So, dito naman is may motion. So, simpleng cancellation lang, mawawala yan. So, we get, so magagamit natin yan yung angle, no, as a friction, no, or coefficient of friction natin kapag meron tayong angle, no. And then, kung hindi tayo given ng coefficient of pressure, no. Next is consider a block that rests on a board, no, and is subjected to no force other than its weight, no, and the board reaction. So the board can be given any desired field. So as long, no, tumataas yung field natin, no, doon sa plane or sa isang surface, no, tumataas din, no, kung saan nagre-react yung reaction force natin. So patulad nito, pumupunta siya dun sa corner, no, kung saan nagre-react na, nag-slip na yung object natin, no, no, opposite dun sa parallel din pala sa surface natin. Okay? So ito, no, makita nyo, no, motion impending, and magkaroon na siya ng motion, which is your theta is greater than your p, no? So yun lang yun, no? And then next is problem involving dry friction. So, ayun, no, problems involving dry friction. So, analyzation na to, no, ng ano natin yung pag iniintindi natin yung isang problem. So, if the body considered is acted upon by more than three forces, no, including the reaction at the contact surface. So, kapag nagkaroon na ng reaction dito, kung saan siya nagkaroon ng contact, no, its components N and F will describe the reaction at each point, and the problem will be solved from the equations of equilibrium. So, if only three forces act on the body concerned, it may be more convenient to represent each reaction by single force, no, which is yung R, and solve the problem by drawing force triangle. So, ano lang yan, no? Sa module natin dun sa past lesson natin, which is yung module 6, no, makita nyo dun yung geometric lang, no? Kapag meron ka forces lang, no, acting on your body, so pwede nyo magamit yun. So, most problem, involving friction fall into one of the following three groups. So, meron tayong three groups. In the first group of problems, no, all forces applied are given and the friction coefficient are known. So, we shall determine whether the body under consideration will remain in rest or sleep. So, mag-sleep siya or hindi. So, mamaya, no, may mga samples tayo doon para malaman natin kung yung ano natin is gumagalaw siya or in motion siya or in state of equilibrium siya or in rest. Okay? And then we have in problems of the second group, no, all applied forces are given and the motion is known to be impending. So we are to determine the value of the static friction coefficient. So malalaman natin yun doon, no? Dito sa figure natin, no? Kasi doon sa una, hindi tayo given ng friction. So equilibrium state lang yun or in motion ba siya or nag-slip pa siya dahil dun sa forces. And then dito naman, no, meron tayong motion impending, no? So the third is in problems of the third group, the coefficient of static friction, no, is given and it is known that the motion is impending in a given direction. So we shall define the magnitude or direction of one of the forces applied. Okay, so sense of impending or movement na siya kung saan siya papunta. Okay, so acting ng weight mo dito, meron kang force dito, friction and your normal force. So medyo same lang siya pero in motion. So, meron tayong example dito, no? The uniform plate shown in our figure has a mass of 200 kg or kilogram. So, if a force P, no, 80 Newton applied in the plate, no, determine if it remains in equilibrium. The coefficient of static friction is 0.3. So, meron tayong coefficient of static friction dito, which is 0.3. So, given natin na meron tayong force, and then hinahanap natin is yung uh, F, yung NC, or yung reaction niya from our surface, and then yung X, or yung movement niya, kung gumalaw ba siya or hindi. Kasi, sabi dito, no, determine, no? Determine natin yung uh, if gumalaw siya or hindi, no? Kung nasa equilibrium siya or hindi. So, first, no, dating gawin natin, nagawa tayo ng free body diagram, no? Yung 20 kilogram natin times the gravity which makuha natin yung weight, no, acting sa center, no, ng ating object. So, nag-apply siya dyan. Meron tayong normal force here, no? And then, ng normal force ng plate natin. Kaya, ano yan, NC. So, depende kayo sa donation, sa denotion nyo. And then, F no, nag-apply no counteract dun sa P natin. So, mapapansin natin kung ano yung unahin natin. So, simpleng tingin lang natin, no? Titingnan natin yung reaction, no, from our P or your force na applied, no, sa plate natin and the friction force. So, simpleng summation of forces lang yan, guys. Okay? So, summation of forces sa X natin. So, simpleng 80 cosine 30 since it's the horizontal force and, okay, minus F, no? So, ito. So, kung ano yung nagka-counteract down, kung ano, yun din sa kabila. So, makuha natin is 69.3 Newton. And then, summation of forces na natin of NC, no? Para makuha natin yung normal force ng plate natin. So, uh, negative 80 sine 30, which is pababa, no? Itong force natin, plus NC, acting pataas. And then, negative 192.2 Newton since dun sa sa weight ng crate natin. So, simpleng makuha na natin yung NC. So, we have F, no, check niyan. We have NC, so check na rin yan. So, yung tatanungin is yung movement, no, of our force, no, kasi ano nagkaroon ka ng movement and nagkaroon ng push, no? Pag sinabing normal force. So, yung mangyayari dyan, hindi siya slip, guys, no? Hindi siya mag-slip. I mean, yung magsa-slide siya. Diyan, mangyayari dyan is yung tipping, kung mapapansin nyo. Di ba kapag may force ka, no? Yung mangyayari dyan, yung may force ka nag-apply dito, so hindi naman kasi yan horizontal na 90 degrees. So, 30 degrees ka, so in-expect natin, sa crate natin, is yung magtitilt siya, no? Magtitilt siya sa ground. Kung magkakaroon siya ng ah, elevation sa ground natin kasi nga nag-apply ka ng force dito so tutulak mo siya. Okay? So, By doing that, para makuha natin kung nagkaroon siya ng movement, no? Simpleng moment of, summation of moment lang, no? From our point of origin. So, 80 sine 60. So, from doon lang sa ano natin, no? From our distance from our origin, no? Moment natin, 0.04, no? Which is given ka naman din dito, di ba? And then, minus, no? 80 cosine, ano nga, kasi since magkakasalubong sila, no? And then, uh, times NCX, no? Dito sa kabila natin. So, along lang din siya, positive. So, NC times X, kasi hindi natin alam kung saan yung force niya or ano yung movement niya or gumalaw ba siya. So, meron tayong 0.00908 meters or negative 9.08 millimeters yung movement. So, check natin yan if ano ba siya, gumalaw ba siya talaga or may changes, no? Kasi compare natin siya dun sa 0.04 kung sobrang taas niya or sobrang laki ng ano niya, inangat niya. So, F max, no, of our force, maximum force, T times your NC, which is given ka ng coefficient of static friction, you have 0.03. So, ano ko muna to, eraser, parang mag-eraser dito. Eraser. So, ito, erase muna natin yan. So, okay. So, F max na yung sinabi natin, 0.3 times our normal force, no? Or your force, no? Acting on your plate. Is equals to 70.9 Newton. So since F is 69.3, which is less than sa 70.9, yung force natin nag-act dito, yung friction natin, no? Mas konti siya. The plate will not slip, although it is very close to doing so. So, ano pa rin siya, no? Hindi siya naggumalaw, hindi siya nag-tilt, no? Doon sa figure natin or force na applied. So, pero ko konti, no? Parang may movement siya pero konti lang. So, next is a 100 Newton force act shown on our 300 Newton block placed on so pounds to the pounds ata. So pounds, yeah. Pounds. Newton na natin. Block placed on an inclined plane, the coefficient of friction between the block and the plane are 0.25 and 0.20. So, ito yung kinetic niya, ito yung static niya. Determine whether the block is in equilibrium and find the value of our friction force. So, simpleng three-body diagram lang din. So, you have to think no kung saan yung mas madaling kunin. So, we have a normal force which is summation of forces lang din yan kung saan ka pwedeng makakuha ng madali. So, given ka ng 100 pounds and then we have FM and FA, no? Yung maximum, no? Friction force natin and then our FA, no? So, first, we'll get summation of forces natin ng X. So, negative 80. So, simpleng ano lang yun din yan, no? Summation of forces at X. Kasi given ka ng 100 dito. So, imagine mo lang na tilt ka in 2D, no? And naka 0 degrees ka. Kumbaga, wala kang angle of elevation. So, given ka naman dito, ng triangle mo. So, simpleng 3 over 5 lang, which is your x component, no? Ng 300 pounds minus f, which is here, no? Is equals to negative 80, no? So, yung movement niya is against, no? Doon sa, ano natin, sa block natin. And then, summation of forces at y lang din, no? Reaction dito. So, makuha ka ng 240, okay? And then, no, since given tayo ng coefficient of friction here, no, ita-times lang natin yun. First is in our, on our um, static friction. I mean, coefficient of static force. And then, times mo siya sa normal force in acting dun sa surface niya, which is here, no, nag-act dito. So, we'll get 60 pounds. And then, actual friction natin, which is simpleng 0.2 no, times dun sa 240 acting din dun sa force natin. So, compare natin siya, which is 48, no, yung nakuha natin. Since, no, the value of the force required to maintain equilibrium, no, which is 80 pounds, no, is larger than the maximum value may be obtained ng 600 pounds natin na nakuha, no? Yung static friction natin, which is ito kasi dapat kailangan niyang ma-maintain. So, equilibrium will not be maintained and the block will slide down the planes kasi mas malaki yung force natin, no? Nakuha ng friction pababa kaysa dun sa nakuha natin na friction na pipigil. So, hindi siya in equilibrium state. Okay? So, our object, no, or the block will slide down to the plane. Next is, ito example natin, no, ng uh, isang ladder. So the uniform 10 kilogram ladder rests against the smooth wall at B. So ito yung B natin, may wall tayo dito, may surface dito, and end rest on a rough horizontal plane. So for which the coefficient of static friction is 0.3. So determine the angle of inclination, no, of the ladder, and the normal reaction of the ladder is on the verge of slipping. So ayun, no. And then, no, wait lang. Okay. So first, no, dating gawin pa rin, no, the body diagram, i-analyze natin siya. So kahit triangle lang naman, no. So same na sila ng height and distance, no. So equilateral siya. Okay. So same sila ng lengths from our horizontal and our vertical. And then, no, solutions na natin nung given required, no. So 10 kilograms daw yung ano natin, yung ladder natin, no, and given tayo ng coefficient of static friction, and then we'll get yung reaction natin doon sa point A at point B. And then may force tayo dito acting in our point A. And then, no, simpleng summation of forces natin at Y. We have a normal force here ng NA natin, which is nagre-react doon sa point A minus, no, sa uh, uh, sa ladder natin, sa weight ng ladder natin. So, simpleng 10 times our gravity lang yan, no? Is equals to 0. And we'll get our NA kasi yun yung, ano, no, yung force na nag-act sa ladder natin. So, kasi summation of 0, di ba? So, yun yung force din na nag-act doon sa NA natin. So, and then we have FA, no? Nag-act dito naman since friction yan, kung slip down nga siya, no? So, uh, simpleng friction times your coefficient of friction times your weight, no? Or your gravity, no? Or your normal force, no? So, makuha natin is 29.43 Newton, no? So, FA, and then, nakuha na natin yung dalawa, simpleng ganun lang. And then, our NB, no? Doon sa taas. So, anong magandang gawin, no? Edi, ano lang, no, vertical, I mean, horizontal forces lang natin. So, 29.43 Newton minus NB. So, equal lang din siya, no, dun sa NB natin. So, makita natin dito. So, we have 3 unknowns lang naman. And then, kukunin natin yung angle niya, kung anong angle ng ating ladder from the wall. So, simpleng summation of forces, I mean, summation of moment. So, 29.43 Newton, no, from our point A, dito, no, so, positive counterclockwise, so 29.43 newtons times 4 sine theta, no? Which is yun yung distance natin from our NB, okay? And then, no, minus nung kasalubong natin, no, yung uh, weight natin, which is 10, no, times 9.81, which is the gravity, times 2 cosine theta, no, distance natin from our point of rotation. So, this is equals to, so lilipat mo lang yan, no, transpose, and then, we know that sine theta over cosine theta is equals to tan. So, tan equals to 1.667, and then, inverse, no, inverse ng tan or arctan is equals to arctan ng 1.667 natin is 59.04 degrees or 59. So, nakuha natin yung angle ng ating ladder, no, na nakadikit sa wall. So, ganun lang, no, yung pagsosolve. So, simpleng analyzation, and then ano lang, concept, no, and summation of forces lang din yan since it is in equilibrium. Okay? And then, yung sa wedges naman, so tapos na tayo dun sa simpleng process, no, or reaction ng mga object natin. Here naman is our wedges. So, ang wedges kasi, no, ginagamit mo, uplift large blocks of stone, like dito, no, tutulak mo siya para iangat mo yung box natin. So, these loads can be lifted by adding a force normally slightly less than the load weight to the wedge. So, furthermore, a properly formed wedge will stay in a place after being pushed under the load. So, due to the friction between the contact surfaces, so wedges can be used for minor change in the place of heavy machinery. So, nagagamit natin yan in our daily lives, no? Yung mga wedges na yan, no? Kung mapapansin nyo. So consider block A depicted in our figure. This block sits on a vertical wall B and should be slightly lifted by pushing a wedge C. So dito itutulak mo siya. So we want to find the minimum force no acting no value that has to be added to the wedge natin no to para ma-move natin yung block. So it's presumed the block's weight no is unknown no. So solve natin yan. So further examples natin, malalaman natin yan. So, considering nun sa free body diagram of our block, no, ito muna ang block A, no, makikita natin yung forces niya nag-act sa kanya. First is yung normal force from our wall and then yung weight niya. So, may friction din doon, no, kasi di ba kung iaangat mo siya pataas, no, magkakaroon ng counteraction dito, which is your friction force, no, na nag-act dito sa side ng block mo. And then, may normal force ka, since ito, kapag tinulak mo yan, itutulak niya yung normal force natin dito, acting on our plate, no? And then, same lang din dito sa friction force natin. So, summation of forces natin, no, is equal to 0. And then, from our static friction ng N2, ang normal force mo at your wedge, no, and minus to our N1 na nag-act dito no, to the left no, sa wall natin. And then, so simpleng ano lang din yan, summation of forces sa Y, or makita natin na R1 no, plus R2 plus W is equal to 0. No? So yan yung nag-act sa atin no, sa forces natin no, nagagaling sa mga nag-act or external forces na nag-act sa ating box no, or plate. And then, kung sa wedges naman, sa wedge natin, no, kung ano yung mga forces na yun, so we have force na pa-down, which is yung weight, no, mapapansin natin dito. And then, our force din sa baba na nag-act doon sa, sa crate natin. So, makita mo yan, no, dito, no, kung mapapansin nyo, yung mga forces na nag-act. And syempre, may weight ka dito, may reaction ka dito, may reaction ka din dito sa block na to. And then, may reaction ka din dito since, no, dito sa part na to, since tinutulak mo, pag tinulak mo yan, no, may friction na nangyayari dyan. So, nakukonsider din natin yon no? So, simpleng, summation of forces lang din, no? Dapat ma-identify mo yung mga nag-act na forces doon, no? So, meron kang reaction forces from here, no? R2 mo, and then sa R3 natin dito. So, mapapansin nyo siya, meron tayong R1 dito kasi doon yung reaction ng isa sa pader, and then meron tayong reaction dito pataas, no? Kasi sa wedge natin. And then, we have reaction din, yung same ng N2 yun, no? Or R2 kasi yung nag-act sa kanya. And then, meron tayong force na nag-act dito sa R3. And then, meron tayong force dito, horizontally, na nag-act, no? Pinupush nating wedge, no? Para umangat yung box na yon. So, simple, summation of forces ng ulit. So, gamit na gamit yun, no? Negative coefficient of static friction times your N2, no? Kasi pababa yan, and then our N3, no? Which is here, no? Itong mapapansin nyo dito, nag-act doon ng friction natin, minus sin 6, no? And then plus P, no? Itong force na ina-apply natin dito. And then our vertical forces, which is yung same lang din, no? Pag ina-analyze nyo yan. So, we'll get this equation, which our force, no? P, no? Or our horizontal force minus sa reaction natin sa R2 plus R3 is equals to 0. Okay? And then, no, meron tayong example dito, the uniform stone. It has a mass of 500 kilograms and is held in the horizontal position using a wedge at P. So, if the coefficient of static friction is 0.3 at the surface of contact, determine the minimum force P needed to remove the wedge. So, assume that the stone does not slip at A. Okay, so hindi yan madudulas dyan, no? Hindi yan matatanggal. So, titingnan natin no, kung ano yung required na force natin kapag binunot natin tong wedge natin, no? Or hinila natin siya, no? So, uh, first, no, same, ano lang, concept lang din. So, we have angle dito, no? So, kung consider mo yung angle dito ng wedge natin, and then we have acting ng mga forces, we have mass, no, stone natin, and then forces natin dito sa wedge, no, sa edge ng stone natin, and then acting tayo dito ng wedge natin, and then meron tayong reaction din dito na normal force and friction dito sa point A. And then consider natin din dito sa point B, no? So meron din tayong free body diagram of wedge, no? Kasi yung force natin diyan ang gagamitin natin kapag tinanggal natin siya, no? Kung ano yung mangyayari, no? Ano yung required na kukunin natin. So first, no, kukunin muna natin NB bago natin ma-apply yun sa ating wedge. Okay? So given naman tayo din ng coefficient of static friction, no? So analyzation lang talaga yan, no, guys, no? So we have angle din dito, given natin angle. So simpleng summation of forces na lang din. So dito, since pala na nakuha yun, no, summation of forces and summation of moments, no? So given required, no, kung pinahanap natin is yung P lang, okay? So minus negative summation of moment natin at A, no? Kasi dito tayo, no, madaling tayo makakuha dyan. So positive, uh, ito, okay? So positive counterclockwise. So positive counterclockwise, no? So we'll get 4,900 5 Newton times yung distance niya from your point of axis, no, or point of rotation. And then, simpleng ND cosine 7 lang din, no, kasi nakuha natin yung angle natin from our ND, no, or your normal force at point B times 1 meter kasi yung distance niya plus, no, 0.3 NB sine 7, no, nag-act dito sa ating stone, no, or ating vertical forces, no, kasi di ba meron tayong forces dito, we have two forces which is vertical and horizontal. And then kapag tinranspose natin yan, makuha natin yung NB which is 2,383.1 Newton. And then, summation of forces since nakuha na natin yung forces natin at dito and yung force natin at NB. So, simpleng NC, yung kukunin natin yung reaction natin or yung force na nag-apply sa NC natin at our wedge, no? So, we'll get 2,452.5 Newton. Okay? And then, no, summation of forces natin at X. So, kukunin natin yung P natin dito since given ka na nito, given ka na nito. So, our weight, no, muna, our weights. Yung reaction natin at B or yung force natin at B, point B. And then, no, summation of forces natin times sa 2,380.1 cosine 7, which is yung horizontal din ng ating NB, no, dito, nag-apply dito, pababa. Okay? And then, plus P, no, times, minus sa 0.3 sa NC natin, which is dito sa lupa or sa surface natin na nag-act dito sa point C. Okay? So, ito yon, no? And then, equate lang natin siya, which is, makakuha natin is 1,154.9 Newton or 1.15 kilonewtons. Okay? So, yun lang, no, yung pagkuha natin. Okay? So, yun yung ano natin, yung force needed, no, para matanggal natin yun or magkaroon ng slip yung ating stone, no, matanggal yung stone natin dyan. Okay, no? So, for our example, no, another example natin sa wedge is the position of the machine block E is adjusted, no, by moving the wedge A. So, knowing that the coefficient of static friction is 0.35 between all surfaces, no, of contact, determine the force P required, no? So, to raise the block and then B to lower the block. So, first natin isosolve daw is yung pag-push, no, dito sa applied force natin sa wedge, no, kung saan magkakaroon ng lift, no? Or aangat yung block B natin. And then, yung second daw na hanapin natin yung um, is yung force, no, to lower the block B. So, first step, no, same pa rin, no, gagawa tayo ng free body diagram. So, we have a free body diagram here. Force na nag-act dito, which is 400 pounds or yung weight natin. And then, reaction forces natin from our point, no, sa wedge natin in our friction sa wall, no. So dito na part. So kasi tinutulak natin siya, kakaroon tayo ng friction dito or reaction, no, from our bottom and dito sa side natin. So paano naging 19.3 yan, guys, no? So di ba nasabi natin na ang friction, no, pwede natin siyang magamit for angle, no, para sa ating friction, no, kapag force, no, force is equals to our coefficient of friction times our force or normal force na nag-act doon, no. So ito, no, simpleng tan, no, tan is equals inverse tan or arc tan, no, times dun sa friction natin, which is 0.35. So yun yung uh, friction na nag-act doon, no. So kapag nag-inverse tan ka dyan or arc tan 0.35, makuha mo yung 19.3. Okay? So, 19.3, no, from our R2, or reaction 2 dito sa side, and then R1 dito sa baba, which is acting dito sa wedge. So, 8, no, which is meron tayong angle dito. 8 plus 19.3 is equals to 27.3 degree, no? So, ginagamit natin yan. So, meron tayong dalawang angle dito. And then, gagawa lang tayo ng triangle natin, which is tatlong forces lang kasi yan. So, we could get the R1, no, from simpleng sine law. So, meron tayong 400 dito, and then meron tayong reaction ng R1 dito and R2. So, 90 plus 19.3 kasi nga, imagine nyo lang, yung act natin dyan is 90 degrees plus dun sa degree na ginalaw or the friction ng ating wedge, no, kapag tinaas siya. So, 90 plus 19.3 is 109.3. So, dito naman, 180, no, minus 27.3, no, since yun yung ginalaw niya from to the left, no, ng ating diagram or ng force natin acting sa ating block B. So 180 minus 27.3, no, minus 109.3, and we'll get 43.4, no. So simpleng yun yung angle natin dito, then may angle tayo dito, no. So simpleng sine law, R1 over sine 109.3, which is yung kaharap, no, nung ating side, no, and then 400 pounds, no, over sine 43.4. So ito yon. So we'll get our reaction, and then pag nakuha natin yung reaction niya, ilagay natin siya dito sa wedge natin kasi yung R1 yung nag-a-act, no, dun sa ating wedge, no. So R1, no, meron na din tayong angle, no, 27.3 and our 19.3. And then, gawa lang din tayo ng triangle. So, we have x component and our forces, no? Forces component natin. So, 90 minus 19.3. So, sa harap ng, ano natin, sa harap ng P, no? Is 46, no? Ito yon, no? Sa baba. So, kaharap ng P is 46. And then, itong 170.7, no? Is kaharap niya nung 549 na nakuha natin from our R1. No? So, yun yung angle niya. So, simpleng sine law lang din, we'll get our force na 423 pounds. No? So, simpleng triangle rule lang din yan, no? Na-apply natin dyan. No? Huwag yung kalimutan nyo, gamit na gamit yung triangle natin dyan. And then, di ba nakuha na natin yung force, no, to raise the block, and then yung pabalik naman or yung pull, no, kung saan matatanggal natin wedge natin. So same lang din, may friction tayo dito, so sa kabila naman yung reaction niya, and then forces lang natin, no, gagawa lang tayo ng triangle. We have R1, sa kabila naman yung turn, no, so 19.3 minus 8 naman yon, so 11.3 dito sa harap ng R2, and then sa R1 naman natin is 98, no? So, 90 minus 19.3 lang yun. No? I mean, dito pala, dito na sign, which is yung R1 natin, no? Kasi ito yung kaharap nun, no? Ito yung kaharap niya. So, R1 is yung 70, which is here, no? Minus 19.3 kasi gumalaw siya, no? To the other side, so 70.7. And then, ito naman, no? Minus 70.7 minus 11.3, which is yung nakuha natin dito from our R1, no? So, makuha natin is 98, no? So, simpleng sine law lang din, R1 over sine 70.7 degrees equals to mga 400 pounds over sine 98. So, makuha natin yung R1 natin or yung reaction natin from our block B. And then, yung block B na yun, no? Mag-apply ulit siya dun sa wedge natin, same procedure na ginawa natin from our previous sample, no? I mean the previous na kinuha natin. So, yung R1 natin is nag-apply dito sa wedge natin, which is sa edge nung kanina. And then R3, no? Nag-act dun sa kabila. So, di ba napansin natin yung kapag nag-act tayo dito ng force, no? Yung reaction natin ng ang R3 natin ng wedge, no? Is here, dito na part, no? Sa kabila. Kasi nga papasok. Since dito naman is palabas, no? Yung reaction naman niya is dito. Okay? And then, simpleng ano lang din, trigo, no? Component natin, no, will create a triangle. So, meron tayong 90 degrees minus 19.3 equals to 70.7. Same nandun sa taas, no? Which is, kaharap, no, ng ating 381 or your R1, no? So, ito yung R1 natin, no? Kasi ito yung pababa, di ba? So, we have R3 here, no? Na nag-create. Pero hindi inanap naman natin dito is yung P. So, kapag hinahanap yung R, pwede mo rin namang makuha yun. So, P yung hinahanap natin, which is yung pag-pull natin, no, sa labas, palabas, no, pull force, no. So, we'll get, meron tayong reaction dito or angle, no. So, 19.3 plus 11.3 na kung saan nakuha natin dito sa part na to. Okay? So, 19.3. So, simpleng sine law lang din. P over sine 30. No? Sine 30.6 degree is equals to 381 pounds over sine 70.7 degree. So, we'll get our pulling force na 206 pounds. So, basic lang siya, di ba? Kung i-analyze mo siyang mabuti. Okay? So, simpleng trigo lang yan and simpleng sine law. And then we have a belt friction naman. Dito naman, medyo complicated lang to in terms of our angle. So, anytime belt drives or band brakes are mounted, the frictional force formed between the belt, no, uh, belt and its contact surface need to be determined. So, we will discuss the frictional force acting, no, doon sa surface natin. So, we will discuss the frictional forces acting on a flat belt in this section. So, such as V belt, so is based on similar principles. So, same lang siya, tensions lang din yan. So, consider a flat belt which passes through a fixed cylindrical drum. No, sa figure natin, we propose to determine the relationship between T1 and T2 values of the tension in the two parts of the belt when the belt is about to slide to the right. So, meron tayong derivation dyan, no, paano natin nakuha yan. So, ito, no, simpleng, actually, ito, ano na lang to, no, ano na, summation of forces natin from X and Y, no, then eliminate natin yung, normal force natin or change in normal force. Kasi nga, no, meron tayong tension dito, kung makita nyo sa diagram natin, no, which our T prime, no, is equals to T times change in tension din. Okay? So, we have ang angle dito na ating angle natin sa dalawa since, pero equal naman yan, no? So, theta over 2, no? Kasi yung tension natin dyan, nag-a-apply dito from left to right, and then our normal force dito sa baba. So, same na siya nag-a-act dyan. So, we could cancel that, no? Eliminate daw yung change in normal force, no? Nag-act dun sa drum natin, no? And then, change in T, cosine change in theta over 2. So, same lang din yan, no? You have to transpose this equation. So, divide 2 by change in theta. So, ayan, no? So, makikita nyo naman yung derivation nyo actually sa module nyo kung paano siya ginawa. So, the quotient of sine change in t over 2 over change in theta over 2 approaches 1. So, since the limit of change t over change theta is by definition equal to the derivative of our change t over change theta, we write. So, ito yung equation, no? So, we have to integrate, no, yung T2 over T1 natin and we'll get this equation which is your theta or your tension 2 over tension 1 is equals to E raised to our friction over your beta. Times your beta. Okay, so Ln, no, logarithmic functions lang yan para ma-eliminate mo yung Ln sa kabila. So, T2 over T1 equals to, so ito yung ginagamit natin, no, to get the tensions natin kung meron tayong given tensions. And then yung ito, don't forget na nagagamit natin siya, I mean itong US na to or your coefficient of static friction, no? Nagamit natin din siya kapag meron tayong angle. So, yung T2 and T1, no, belt tensions yan, no, counteract the direction of motion or impending motion in the measure belt relative to the surface, while T2 acts in the direction of relative belt motion, no? So, because of friction, so our T2 is greater than our T1 or tension 1. So, static or kinetic coefficient, no, of friction yan. And then, angle of belt to surface contact measure yung beta, and the natural logarithm ng E, no? So, sa calculator nyo yan, meron din yan. So, note that the tension 2 is independent, no, of the radius of the drum. So, instead of its function of the angle of belt to surface contact, which is your beta. Okay, so ito gamit na gamit yan, no, kapag natin, yung pinag-aaral natin is yung belt friction. Okay, so we have an example here, no, hawser thrown from a ship to a pier is wrapped two full turns around a bollard. So, ito yon, no? So, meron kang tali dito, may tension dito. So, nagpupul ka ng dalawang tension. So, the tension in the hawser is 7,500 Newton. No? So, by exerting a force of 150 Newton on its free end, dock worker, dock worker, a dock worker can just keep the hawser from slipping. So, determine the coefficient of friction between the hawser and the bollard. Nung dito sabihin natin, itong malaking to, parang ilaw. Pero hindi talaga ilaw yan. Yung parang ginagamit sa mga pier or dock natin kapag tinatali yung barko. Okay, so determine the tension in the hawser that could be resisted by the 150 Newton force in the hawser will wrap 3 full turns around the bollard. No? So, since the hawser is wrapped 2 full turns around the bollard, we have our beta, no, times 2 kasi dalawang rotation yan, no? Times 2 pi, no? So, we could get this 12.57 rad, no? So, our tension 1 and tension 2, nakuha na natin. So, i-apply mo lang, no? Hinahanap lang naman din is yung friction natin. So, try to solve natin, no? Sa calculator natin, no? Kung anong makukuha dyan. And, nakarad yan, no, guys, no? Yung dito. So, mapapansin nyo. Okay? So, try natin, no? Yung ln sa calculators natin. No? Sabay-sabay tayo mag-solve. So, check ko rin kung nasarad ba to or hindi kapag sinet sa calculator. Okay? So, hindi na no kailangan kasi nga since na-convert na rin din yan sa rad natin, sa calculator natin. So, 0.3112 yung lumabas. So, goods na din yung na friction niya. Kasi kanina, di ba, nag-convert din tayo ng friction to rad. So, goods lang yun. Okay? So, di na kailangan i-change sa rad yun since ito is naka degree na siya or yung rotation na ng 2 pi natin. Okay? So, next example natin is yung hinahanap pa pala dito no yung ano natin yung force natin at our tension 2, no? So, kapag ginamit natin yun, yung nagkaroon tayo ng tatlong tension na hawser could be resisted by the force we're up to. Ito naman is 3 full turns naman yung hinahanap niya. No? So, kanina hinahanap natin yung sa friction natin. So, we could use that friction, no, dun sa ating formula, no, na T2 over T1 is equals to our natural logarithm, no, raised to our coefficient of friction times our beta. Okay? So, 3 turns daw. So, 3 times 2 pi lang yun. And then, tension natin na 150. And then, our coefficient of friction. So, T2 over 150 newtons equals to E raised to 0.311 times your 18.85. So, we'll get the 150 Newton times E raised to 5.862 and we'll get our tension na 52,725 Newton. So, yan yung force no sa tension 2 natin dito sa kabila. Okay? And then, meron naman tayong flat belt dito. So, I think this is the second to the last no, na sample problem natin. So, flat belt connects pulley A to pulley B. So, the coefficient of friction R. So, given naman tayo ng coefficient of friction natin dito. So, between both pulleys and the belt. So, isa sa pulley and isa sa belt. So knowing the maximum allowable tension in the belt is 600 pounds. So determine the largest torque which can be exerted by the belt on pulley A. No? So since the resistance to slippage depends upon on the angle of contact ng beta natin between pulley, so yung rotation yun, as well as upon the coefficient of static friction, and since no sa ating coefficient of friction is the same for both pulley, slippage will occur first only pulley B. So sa pulley B muna siya for which beta is smaller. So T2 is equals to 600 pounds, no? Then our coefficient of friction is 0.25 and our beta is will get na convert natin 120 no to pi or sa rad no. So 2 pi over 3. So gamitan na natin yung formula natin to get the tension sa T1 natin no. So this is the free body diagram natin. So wag natin siya kalimutan to analyze natin kung ano yung hinahanap natin, unknowns and kung ano yung gusto natin hanapin. Okay? So, T1 is equals to 600 pounds over 1.688 since ito yung nakuha mo no, from your right side no, ng equation. And then, simpleng transposition lang will get our T1 na 355.4 pounds. And then, no, we draw the free body diagram of pulley A, the couple, no, MA supplied to the pulley by the machine tool to which it is attached and equal and opposite to the torque exerted by the belt. So, summation of forces natin sa point A. So, nung makita natin dito, no? Yung summation natin dito, I mean, dito tayo magmo-moment, summation of our moment. And then, simply makuha na natin is MA minus, no? 600 pounds, 8 inch, which is your radius, no? From your tension 2 and 1, no? So, 600 pounds times 8 inch and then 355.4 na nakuha natin kanina dun sa tension 1 natin since given naman tayo ng tension 2. So, sa MA, no, from our moment at A, we'll get this 1,957 pound inch or 163.1 pound foot. Okay? So, yun lang, no? Kung ano lang siya, simpleng input lang din siya, no? And analyzation ng pulleys. Okay? And then, ito, last sample natin, no? So, the maximum tension that can be developed in the cord, no, is 500 newtons. So, if the pulley at A is free to rotate, no? And the coefficient of static friction at the fixed drums B and C is 0.25, determine the largest mass of the cylinder that can be lifted by the cord. So, hinahanap natin is yung mass, no? Na kayang buhatin ng ating cord. Okay? So, ito yung tension natin, no? Na kung saan yung force na kaya niya. Okay? Dito. So, lifting the cylinder, which has a weight of simpleng mass times gravity lang causes the cord to move counterclockwise over the drum at B and C. So, dito yun, no? Sa B and C natin, meron tayong pulley na A. Hence, the maximum tension T2 in the cord occurs at B. Okay? So, i-analyze natin siya from B, no? So, B to our tension and then B, 500 Newton na tension na sabi dito. No? So, given naman tayo no, ng tension natin from our drum D. No? So, simpleng gamit lang ulit ng formula natin para makuha natin T1 which is acting dun sa pulley natin. So, input mo lang din. So, 135 degrees, no? Pending motion natin doon, no? So, we'll get the 3 pi over 4. So, convert mo lang ulit yun to our rad, no? Para magamit natin siya sa natural logarithm. And then, 500 newtons over T1 equals to E raised to 0.25, which is given naman din dito, no? Sa ating, sa problem natin na yung friction is 0.25. Okay? And then, times mo lang siya and we'll get our tension 1 no, na magagamit natin. So, saan natin gagamitin niya yung tension 1 na yan? Simply by acting lang dun sa ating point C. So, makita yung sa figure natin, no? Dito sa figure natin, so may tension tayo, di ba, dito na 277 and then meron tayo tension dito na dapat nakunin from our C. Okay? So, since the pulley at A is free to rotate, equilibrium requires the tension in the cord remains the same on both sides of the pulley. So, due to maximum tension of the cord is 500 Newton, we can say that the weight should be um, uh, less than 277.4 Newton, no? Which is our weight, no? Is equals to our T1. So, T2, no? Since T2 natin sa kabila, no? Makita dito. So, nakuha naman natin yung T2 dito from our side, no? Sa pulley natin sa A. And then, makuha natin siya by saying na yun yung na mas greater intention natin dito sa T2, which is yung 277.4. So, we'll get our weight, no, or weight or force na nag-apply dito sa C na 153.9 Newton. So, simpleng weight, no, yung weight is equals to mass times your gravity. So, lipat mo lang, divide mo lang siya sa gravity and we'll get your mass na 15.7 kilograms. So, yun yung kayang buhatin nung ano natin, nung cord natin or nung cable natin, no? So, since giving ka dyan, so kapag pinataas din yan, so mas mataas yung weight na kaya niya. Since ito lang kasi yung given, yung 500 na na tension na nabubuhat. Okay? So, sa ibang problem kasi kapag kino-consider, especially sa strength of materials yan guys, no? Kino-consider yung strength, no? Yung ano niya, kung mapuputol ba siya or hindi sa ganung tension or weight na kaya niya. So, sa susunod pa yun, no? I mean, meron na kasi mga deformation doon, no? Strength of materials natin na kino-consider niya. Okay? So, kung may questions kayo, no, pwede nyo ako message since magkakaroon kayo ng quiz, no? So, lahat naman to guys, no, galing sa module nyo. And then, um, practice lang talaga, no? Kagaya nga ng sinabi ko, yung mga learning activity dyan, no? Gamit na gamit yan. Okay? So, kung may mga questions kayo, no, our discussion, pwede nyo naman akong tanungin, no? So, good luck sa parating na quiz and then sa mga susunod na lessons, no? Since ano pa yan, no? Marami pang reactions, I mean, marami pang tayong isi-solve like mga forces, mga trusses natin. So ito, about lang naman sa friction since dun sa past module nga natin, no, discuss ko dun, yung acting, no, sa mga supports natin. So, yan, kunyari yan, no, merong structure and then meron kang ganun, mga forces applied and then moment and summation of forces and then may friction ka pa na nag-a-apply dun sa body mo. So, samo-samo yun, okay? So, ano lang talaga siya, practice lang talaga and then ano lang, analyze lang talaga free body diagram and given required and then more sample problems. No? So makikita nyo naman to sa internet. No? So yun nga, no? For kung may mga questions kayo, no? Clarifications, don't hesitate, no? Na mag-message sa akin or ask your representatives, no? Para dito sa lesson na to. So, thank you for listening and I hope na may natutunan kayo sa video na to. So, good luck and goodbye.